All right, so let's look at number 3. The first thing we have to do is to factor. So this will be x minus 3 times x plus 2 over. Now, when I factor this, you can factor it into x plus 4 times x plus 4, and that's fine. But if you get it that way, then you need to make it into x plus 4 squared. So if you don't recognize that right off the bat to just put it in that form, that's fine. You might end up with x plus 4 times x plus 4, but then you've got to make it into squared, okay? Do I have any point discontinuity? No, so there's none here. Oh, also, it's probably obvious, but I put colored pencils on your table. I should have done that yesterday. You don't have to do anything in color, but when we get to the graphing, if you want to graph asymptotes and whatever in different colors, you can. All right, so how many roots do I have? 2. I have a -2 into 3. Then how many vertical asymptotes? 1. X equals -4. Do I have any tangency or togetherness? Yes, so it's been a while since we talked about it, but yes, we have it. And so if you always say them together, tangency and togetherness, tangency is in the numerator, togetherness is in the denominator. So since this factor is squared, that means I'm going to have togetherness. I'm just going to put TOG at that asymptote, which is x equals -4. Okay, and then we'll talk about what that means and what we do with it in just a second. All right, am I going to have a horizontal asymptote? Yes. Y equals what? 1. That means there's not a slant asymptote. And then the y-intercept's easier to get from the non-factored version. It'll be 0, -3/8. And then I'm going to rewrite the factored version right here so I can see it when I scroll. F of x equals x minus 3 times x plus 2 all over x plus 4 squared. Okay, so then we're going to make our number line, our sign chart. So on here I'm going to have a -4, -2, and 3. So the -4 is my asymptote, that's open. These are both closed. Okay. So if I substitute in a -5, that would give me negative. The denominator is going to be positive no matter what because we're squaring it. And then that's positive overall. If I use a -3, that would give me negative, positive. That's positive overall. Then I can use 0, so I'll have negative, positive. It's negative overall. Use 4, that'll give me positive. So this is what my sign chart looks like. Oh, that is not what that says positive. Positive, negative. Oh, let me write that positive. Okay, so remember that your open circle here, this represents a vertical asymptote. And so on either side of that vertical asymptote, you can see that your function is positive. And that's where we have our togetherness. Our togetherness is at x equals -4. Remember, togetherness means that on either side of the asymptote, they're both pieces are going to infinity or -infinity. So it looks pretty much like that's going to have to be there, and then that's going to have to come like this, right? Then this is a 0, so I'm going to have to cross through and become negative and then positive again, and I don't know exactly what that shape looks like, but that's what my togetherness means right there. So we figure that out from the function, and we can figure it out from the sign chart. Okay. So on our graph, let's go ahead and get our asymptotes on there. I always want to do those first. So the vertical asymptote at 1, 2, 3, 4, x equals -4. Horizontal asymptote at y equals 1. And then I'm going to plot what I can plot. I've got my roots at -2 and 3. My y-intercept is 0, -3/8. So 4/8 would be a half, so it's about a half. And it doesn't matter on here, can't get that accurate anyway, so about right there. Okay, so that's everything I can get on there from the information that I found. So clearly I'm going to have to find some other points. I know from -infinity to -4 my function's positive, so it should be something like this, but I got to get some points in there. So we'll start with f of -5. So that would give me -8 times -3 over 1. So that's 24. That's way off my graph. That doesn't help me at all. So we'll try f of -6. That would give me -9 times -4 over 4. So that's just 9. I can get that one on there. So -6, 9 is right there. But that 1 point doesn't really help me that much. So I'm going to have to do f of -7. So it'll give me -10 times -5 over 9. That's 50 over 9. How many times does 9 go into 50? 5 with 4 left over, so it's about 5.5. So I can go to -7 and then 1, 2, 3, 4, 5.5, and that's probably good enough. Now, I'm not going to draw it in just yet. I'll tell you why in just a second. Because remember, it's possible for you to cross a horizontal asymptote. And yesterday we didn't check for this for a couple of reasons. I'll talk about why in the end. But I can tell over here, I definitely crossed this. So I know it's going to cross at least once. Because from my sign chart, if this shape is going to be like this, and then this has to start up here, well, it's going to have to start up here. I'm going to have to cross the asymptote to get to this point, and then it comes down here, and then maybe it crosses again up here and then comes down, or maybe it stays underneath. And maybe this one comes down and crosses the asymptote. Like, I don't know. I know for a fact it's going to have to cross at least once, but maybe it's more. So I need to check before I sketch things in so I can take that into account. Does that make sense? Okay, so when the first time that you went to check to see if things intersected on the coordinate plane, you were doing systems of equations, right? You could graph two lines. If they intersect, boom, that's their point of intersection. Then algebraically, you could solve them both for y and then substitute, or you don't even have to necessarily solve them both for y. But our two functions that we're looking at are both solved for y. We have our original function, which we would want the unfactored version of. So we have y equals x squared minus x minus 6 over x squared plus 8x plus 16. And I want to know, where does this function cross that asymptote, which is y equals 1? Right? So they're both functions, they're both equations. So to solve this algebraically, I am going to substitute. I'm going to substitute this in for y right here. So I'm going to get x squared minus x minus 6 over x squared plus 8x plus 16, and that's going to equal 1. Okay. So now I have to solve for x. So the first thing I want to do is get rid of my fraction, so I can just multiply both sides by the denominator. So basically, I'm just going to multiply this by 1. So I get x squared minus x minus 6 equals x squared plus 8x plus 16. Everybody understand where anything's coming from? We're just solving at this point. So then here, I would subtract x squared from both sides, and those just zero out. That's nice. It's not a quadratic anymore. Then I'll take this negative x and I'll add it over here. So I get -6 equals 9x plus 16. I can subtract 16 from both sides, so I get -22 equals 9x. So x equals -22 over 9. I got one answer. That means that it crosses it crosses the horizontal, the y asymptote. What am I trying to say? The horizontal asymptote. Why can't I get the words out of my mouth? It crosses the horizontal asymptote exactly once. That's it. And that's the x value at which it crosses it. So 9 goes into 22, twice with like 4 left over, so it's about 2.5. So at about -2.5, that's where we cross, so we have this point right here. So that tells me a whole lot. That tells me that over here, I can go ahead and sketch this part in. It's not going to cross the asymptote, just going to follow along there. I know that I have togetherness here, so this has to start up here. it's going to cross the asymptote right there. I have to come down, it's negative, then it's positive again, and then it is going, so this is middle behavior, it's fine that it crosses, but my end behavior, it's going to be approaching 1, but it's going to have to approach from underneath because I don't get to cross again. Okay, does that make sense to you? That's how you know whether or not you're crossing. So I'm going to go here, like this. It would be possible to cross again and come up and kind of have to go back down and like that, but that's not what's happening here. What questions do you have? Anything? Mm-hmm. It'll always be the function equal to the asymptote. Yes and no. Okay, so that's a good question. I'll go ahead and talk about that now. So on number, if you look back at number one, we should have checked it and we didn't because I didn't want to get into it yesterday, and so you didn't even know it was the thing. I just kind of went with it, okay? But we should have checked it. On the second one, we didn't need to. So let's look at number 2 and understand why we didn't need to here. Here, my asymptote is at y equals 0. So if this was supposed to come up and cross the asymptote and come back down, then I would have to have a 0 here. Does that make sense? And I don't have one. So I know for a fact from my sign chart that this is negative the whole time. So there's no way it can cross that axis, so I don't even need to check. Okay, so most of the time if the asymptote is actually at y equals 0, then you won't need to check, or if and you might have some zeros, then you know that it does. But otherwise, we pretty much need to check on all of them. Okay, good question. Anything else? All right, so let's look at the last one then. Oops. All right, so we're going to start by factoring. So we get x minus 1 times x minus 3 over x minus 2. Do I have any point discontinuity? No. My roots are 1 and 3. Vertical asymptote, x equals 2. Any tangency or togetherness? No. Am I going to have a horizontal asymptote? No. I have potential for I'll have a slant asymptote because it's 1 higher, right? And how do I find the slant asymptote? Divide. And so again, I want the unfactored form to do that. And I can use long division or synthetic division. Could I use synthetic division on this one? Yes. Then personally, that's what I would choose. So we'll put the 2 out here. Then in here, I have 1, -4, and 3. So I bring down my 1, this is 2, -2. Once I get that, I don't care about the rest because I don't need the remainder and I'm not actually dividing. All I need is that. So this is y equals x minus 2. So for my y-intercept, that's also easier from the unfactored version. So this is 0, -3/2. So again, I'm going to rewrite mine so I can see it. While I do that, you go ahead and get your sign chart made, and then I'll make mine. Do y'all agree with my sign chart? You give enough time to finish that? Okay. All right, so let's get our asymptotes on here. Got x equals 2. and then y equals x minus 2. So I got a y-intercept of -2, and then my slope is just 1. Goes diagonally through the little boxes. Then I can plot my points. I've got, what am I doing? 1 and 3, 1 and 3, and 0, -3 halves right here. So really, as far as the amount of, I should use different colors, the points that I have, I don't feel like I need to find any other points because clearly I don't have anything down here. I mean, it looks like it should follow these asymptotes like this and like this, but I can possibly cross a slant asymptote just like I could cross a horizontal asymptote. You will never cross a vertical asymptote because that changes the domain, but I could cross a slant asymptote. So I'm going to start with my original unfactored version, x squared minus 4x plus 3 over x minus 2. Instead of saying it equals y, it's going to equal what y equals for your slant asymptote, which is x minus 2. The fact that these two things are the same is a coincidence. So make sure you understand where I got this from. It's because that's what your slant asymptote is. Make sense? Okay, so just like on the other one, I'm going to multiply both sides by the denominator. So I'm going to get x squared minus 4x plus 3 equals x minus 2 times x minus 2. So I need to go ahead and multiply that out. So I'll get x squared minus 4x plus 3 equals x squared minus 4x plus 4. So then I just start solving. I'm going to subtract x squared from both sides. Those zero out. I'm going to add 4x to both sides. Those zero out. That leaves me with 3 equals 4. Is that a true statement? Nope. So since you got something that doesn't make any sense, that means that they don't intersect. Okay? So if you get an x value or more than one x value, it's telling you that's where it intersects that asymptote. So let's say that I had gotten x equals 4. If I had gotten x equals 4, then that means at 4 it's where I'm actually crossing the asymptote. Okay, and that would like cross up and then, you know, hug it from the other side. But I got something crazy, so it doesn't cross at all. That's what that means for you. And then I think that this is enough points because you know it's got to follow the asymptotes. It's going to look like that and like that. Okay. But it is possible, even with slant asymptotes, that like maybe I didn't have a point over here because of whatever, that I need to actually substitute something in so I can find my pieces. But we're good? What questions you got? Anything? Awesome.